Today we're going to be talking about exponential growth and decay. Exponential growth is a function that models how things grow over time. Specifically when you're thinking about things doubling or tripling in size over a certain amount of time, like population or bacteria or mold, something like that. And decay is that same idea. When something reduces itself over time, over at a fixed interval, kind of like the half-life of certain elements. So first thing we're going to do is talk about the equation that represents exponential growth and decay. Exponential growth and decay can be modeled by the equation y equals ab to the x. A usually refers to your starting amount. That's the amount of whatever value, whether it's people, bacteria, whatever, that you've been given. Another way to look at it is the y-intercept, since it's pretty much where the graph is going to cross on where x equals 0 on your graph. The next value over here is referred to as your base. Now this can either be referred to as a growth factor or a decay factor. Finally, we have the exponent, and that refers to the interval period. After how many years, after how many months, etc., so forth, that the item is growing. So let's go ahead and put this all together in an example. Since 2000, the daily cost of patient care in community hospitals in the United States has increased about 8.1% per year. In 2000, such hospital costs were an average of $1,480 per day. What is that cost in 2012? All right, so first thing we're going to do is start off with our initial cost. That was, at the start in 2000, $1,480 per day. Then we're going to include our growth factor, which is 1.081. Where does that 1.081 come from? Well, we have 8.1% per year, but you're also adding on that 8.1% to the previous year, which we label as 100%. So you had 100% of the value the previous year, plus 8.1% in the next year gives you the 1.081 that you need in your equation. Finally, we need our exponent, our interval. How many years have passed since 2000? So in this case, we're going with 2012, so we're going to show 12 as our exponent. Now what I want to do is go ahead and solve this. In order to do that, I need to remember my rules here. So please excuse my dear Aunt Sally. I'm going to take this 1.081, take it to the 12th power, and then I'm going to multiply it by 1480. And that's going to get me my answer of about $3,768.51. So that same cost that same daily cost of patient care will now cost $3,768.51 in 2012. Let's go ahead and try one on our own. And when I say us, I mean you. So, since 1980, the number of gallons of whole milk each person in the U.S. drinks each year has decreased 4.1% each year. In 1980, each person drank an average of 16.5 gallons of whole milk per year. Write an equation to model the gallons of whole milk consumed per person. So you're not necessarily looking to solve it, but you're looking to set up an equation. Why don't you go ahead and pause and do that now? So, what happened? Let's take a look at your equation. If you wrote down something like y equals, let's see, let x equal the number of years since 1980, let y equal the consumption, the gallons of whole milk consumed, let a, so my initial starting amount is going to be 16.5, and B is going to be my decay factor. So if you wrote down 16.5 times 1.041 to the x, you would be wrong. Here's why. Let's take a look right here at the 1.041. So the one thing to notice is that my amount has decreased by 4.1% each year. So if it's decreased by 4.1%, then how much remains each year? Well, if I take 100% from the year before, and then I subtract 4.1%, then I'm left with 95.9%. So that means if we think back to our equation, y equals a times b to the x, remember that b now is a decay factor. Another way to think of it is I have to have a number less than 1, or else my value would keep growing, and I don't want it to grow. I want it to decrease because I'm showing a decrease. So then let's rewrite our equation. I'm going to have y equals 16.5%, that's cool, or sorry, 16.5 gallons, times, now I need to model 95.9%, so that's going to be 0.959 to the x. And that x is going to depend on how many years later I want to create that equation. One thing to think about is, will this ever reach 0? Just to think about for a while. All right, here is a challenge problem. So let's see if you can put it together. Suppose you use your MasterCard to purchase a new suit for $400. If you do not pay the whole amount the first month, you are charged 12% monthly interest on your account balance. Suppose you can make a $30 payment each month. Two questions. One, how many months will it take for you to pay off the entire bill? Two, how much interest will you have paid in all? So, how much will that $400 suit really end up costing you? Enjoy!